So good morning students, in continuation with 8C numericals. So we are having the sixth question. A bulb of power 40 watt power is given to us, okay, are used for 12.5 hour each day for 30 days. Okay, so what will be the we have to calculate the energy. So energy for one day we will calculate, and from there we can calculate the energy for the 30 days. For one day it will be energy is equal to P into T. So you will get it as 40 into 12.5, and for 30 days we multiply this value with the 30. Okay, so the answer here we are getting in kilowatt hour. As in this bacha, there is no need to change the units because watt hour we can use, and further we will have the value in kilowatt hour. Seventh question. An electric press is rated 750 watt and 230 volt. Again, power is given to you and voltage is given to you. So calculate the electrical energy consumed by the press in 16 hours. So simply E is equal to P into T. Put down the values and you will get the answer. Eighth question. An electric appliance having a resistance of 200 ohm is operated at 200 volt. Resistance is 200 ohm. Voltage is 200 volt. Calculate the energy consumed by the appliance in 5 minutes. Time is given to you 5 minutes. Okay, and we have to calculate the answer in joules and in kilowatt hour. So first of all, very simple, we will calculate the energy by using the formula that the values which are given to us V, T and R, accordingly that E is equal to V square T upon R. Putting down all the values, you will get the answer in joules, and you know that 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joules. So if 60,000 joules are there, so calculate the answer by using a unitary method and you will get the answer. Next, ninth question here we are having. A bulb rated 12 volt 24 watt operates on a 12 volt battery for 20 minutes. Power is given, voltage is given, okay, and we have to calculate the current. Time is also given to us. So current, how we will calculate? P is equal to VI, I is equal to P upon V, and energy is equal to P into T. So from here we will get the value of energy. All the simple formulas here, bacha, we are using all the converting formulas which you have done in the chapter. Directly we are using that formulas to get the answer. The 10th question. A current of 0.2 ampere flows through a wire whose ends are at a potential difference of 15 volt. Calculate the resistance of the wire and heat energy produced in 1 minute. Now current is given to you, that is 0.2 ampere. Okay, voltage is given to you 15 volt. T is given to you 60 seconds. So now they want us to calculate the resistance. But the resistance is equal to V upon I. You will get the value of resistance. Okay, and heat energy is I square RT. Putting down all the values and you will get the answer. Okay, the next question is 11th question. What is the resistance under a normal working conditions of an electric lamp? We have to calculate the value of R. If voltage is 240, okay, and power is 60 watt. If two such bulbs are connected in series across a 250 volts main supply, explain why each one appear less bright. Okay, now both the lamps you are using in series, and you know in series what will happen? Voltage vary, current will remain same and voltage vary, so that's why the brightness will reduced. Okay, so now what we are having here, power is given to us, voltage is given to us, okay, and we have calculated the value of R, which comes out to be 960 ohm by using the formula V square upon R, and I is equal to P upon V, which comes out to be 0.25 ampere. Okay, so when two of them are in series, so what will happen? The resistance is what? The resistance value will increase as R1 plus R2 it will be. So in totality what will happen? The value of the current will reduce. So that's why the brightness is less. Next we are having question number 12. Question number 12 is Question number tells you two bulbs are rated 60 watt and 220 volt. Okay, 60 watt and 220 volt, 60 watt and 110 volt. So V1, V2 we are having, and P1 equal to P2 is there. So calculate their ratios. Very simple, we have to calculate the ratio of their resistances, and resistance is equal to V square upon P. In both the cases, put down the value V square upon P. You will get the value of R1 and R2, and then find out the ratio of R1 and R2, which comes out to be 4:1. 13th question. An electric bulb is rated 250 watt and 230 volt. Okay, and calculate the energy. Energy is equal to P into T. And here how much value of T is given to us? They are asking for 1 hour. 1 hour means 3600 seconds. So E is equal to 250 into T. You will get the answer. Second question, the time in which the bulb will consume 1 kilowatt hour energy when connected. We have to calculate the time now. Okay, how we will calculate the time? Putting down all the values, like P into T is equal to energy. So when you put down the values, you will get the value of the time. And here the energy consumed, they have already given us the value of electrical energy, that is 1 kilowatt hour. We are taking it as 1 watt hour, that is equal to P into T, and we will get the value. Okay. Next question, 14th question here we are having. 14th question, we are having 3 heaters, okay, each rated 250 watt and 100 volt, and they all are connected in parallel to a 100 voltage supply. Calculate the total current taken from the supply and the resistance and the energy. See, power is given to you and value of voltage is given to you. So current is equal to P is equal to V into I. So current is equal to P upon V. You will get the value of the current. Now the value of the current for 3 resistors. Okay, value of current for 3 resistors we are having. So that will be 3 into 2.5, and for resistance is equal to V upon I. So R is equal to 40 ohms. Current value is 7.5 for all, and R is equal to 40 ohms. So T is equal to 5 are given to you. So energy is equal to P into T. Putting down all the values, you will get the answer. Very simple numericals. You just know the formulas and you will get the answer. 15th question. 15th question is, a bulb is connected to a battery of potential difference 4 volt and internal resistance 2.5 ohm. Small r is given to you 2.5, potential difference is 4 volt. A steady current of 0.5 ampere flows through the circuit. A steady current is flowing. We have to calculate the total energy supplied by the battery in 10 minutes. So total energy supplied will be V square T upon R. Okay, and R is equal to V upon I. So we'll get the value of R as 8 ohms. E is equal to V square T upon R. Putting down all the values, you will get it as 1200 joules. Battery resistance is given to us, that is 2.5 ohm. Okay, so the resistance of bulb will be how much? Total resistance minus 2.5 ohm, that is 5.5 ohm. Energy dissipation is equal to I square RT. So value of I is with you, that is 0.5 ampere given to you. The energy of the resistance of the bulb you have calculated, that is 5.5. Okay, and T we have already calculated for 10 minutes, that is was 10 into 60, and that comes out to be 600 seconds. Putting down all the values and you will get the answer. Next we are having next question, 16th question. So 16th question is, two resistors A and B of resistances 4 ohm and 6 ohm respectively. Wait. 4 ohm and 6 ohm respectively, and voltage here is equal to 6 volts. Okay, and now they want us to calculate. They are saying calculate the power supply to the battery and power dissipation in each resistor. So one resistance is given to you, resistances are given to you, that is 4 ohm and 6 ohm, and they are connected in parallel, so total resistance comes out to be 2.4 ohm. Power is equal to V square upon R, so power is calculated as 15 watt. Now power dissipation is P is equal to V into I. So current across it, you will have it. For IA it will be different. For next we have calculated the current as IA, and we have calculated the value by using the resistance RA. So power comes out to be 9 watt. And similarly for the B we have calculated, and power dissipation is come out to be 6 watt. Separately we have calculated the powers in both the cases, as current is IA and IB according to the resistance RA and RB. Okay, because in parallels we know that current splits, current varies, so we calculated separately for both the parts. 17th question, a battery of EMF 15 watt and internal resistance 2 ohm, okay, is connected to two resistors of resistances 4 ohm and 6 ohm joined in series. Now we are having two resistances in a given circuit and the internal resistance also. So the resistance given in the circuit, that is 4 ohm and 6 ohm, and the resistance in the internal resistance is 2 ohm. So total resistance of the body is 12 ohm. Okay, and we have calculated the current by using V upon R, that is I comes out to be 1.25 ampere. Now voltage across R2, I will remain same bacha. So voltage across R2, so V2 is equal to I into R we have calculated. Time is given to us, that is 1 minute, that is equal to 60 seconds. So similarly we have calculated the energy for it, that is V square T upon R, putting down the values and you will get the answer. 18th numerical, water in an electric kettle connected to a 220 volt supply takes 5 minutes. So take 5 minutes. How long will it take to supply the voltage of 200 volts? So what we are having, power is equal to V square upon R. So heat gain will be equal to heat loss, the energy conservation. So on one side you are having the voltages on both the sides. Basically we have to calculate how long it will take. If first of all it's taking 5 minutes, then what is the time it taken in the second minutes? So heat gain is equal to heat loss, and when you compare it, you will get the answer, the value of the T. By using the formula, you can see that is V1 square R into T1 is equal to V2 square R into T2. You are having the value of V1, V2, R and R in both the cases. So 1 T is with you, so value of T2 can be calculated. So the last portion now we are having 19th, 20th and 21st numerical. The 19th numerical is, yes, an electric toaster draws a current of 8 ampere in a circuit with the source of voltage 220 volts. Voltage is given, current is given, time is given, okay, and energy is equal to VIT. Very simple, you put down the values, you will get the value of energy. Per kilowatt hour cost is given to you, so 3.52 into 4.50, you will get the answer. 20th question, an electric kettle is rated 2.5 kilowatt and 250 voltage. Okay, time is given to you, V is given to you, P is given to you, energy is equal to P into T. Again cost is given to you, you simply multiply it and you will get the answer. 21st question, a geyser is rated 1500 watt and 250 voltage. Power and V is given to you, we have to calculate the current. Current is equal to P upon V, you will get it. In second case, time is given to you, that is 50 hours, so E is equal to P into T. And cost for per energy is 4.20. So what will be the cost for 75 kilowatt hour? Simply multiply and you will get the answer. But in this question, especially for 8C, first of all on one page write down all the formulas which we are having for power, for energy, for voltage, for charge, so that it's easy for you to find out which formula you have to use at which place. Thank you very much. Queries we will discuss in the class.